Exploratory data analysis, popularly known as EDA, is a method of using descriptive statistics to spot outliers, identify missing data, and apply imputation techniques to fill missing gaps within your data sets. In today's live stream, you will learn all about EDA in Power BI and how it can help you to discover relationship between variables, that is both continuous and categorical variables, by using statistical measures. So welcome back to the channel and welcome to Excel Island, where the goal and objective is to learn Power BI over the next 100 days. And today is day 50. We are 50% we're 50% out of 100 days of learning journey. So welcome to the channel one more time. So also all data exercise files, Power BI files is already linked under the YouTube description. Do make sure to download those files and practice along with me. So few days ago, we started a new course in the old career track, which is Exploratory Data Analysis. On the first two live stream, we actually got introduced to what is Exploratory Data Analysis Power BI. We also talk about distribution and outliers on the second chapter. So we've covered 2 chapters out of the 4 chapters in this course, out of the 17 courses in the whole career track. So on today's live stream, we'll be moving to the 3rd chapter, which is all about using box plots and descriptive statistics to determine how continuous variables influence a categorical variable. So welcome back to the channel. Do support the channel by hitting that subscribe button, put on the notification bell to be the first to know whenever I go live or drop a new content on the channel about my learning journey so far. So if you want to catch previous live stream or previous lessons on the channel, go to the live stream tab. You'll see from day 1 of Power BI to day 50, and I look forward to seeing you on day 100. So let's get back to learning and welcome back to the channel. So if I just go to my DataCamp platform real quick. So we're actually using the DataCamp platform for this learning journey, and we are on the course out of the 17 courses. Let me go to the career track section real quick to show you what it looks like. You can see we are on the career track data analyst in Power BI, and we are 68% out of 100%, and today is day 50. That means we are moving at a good rate and we are not lagging behind. So when I started this learning habit, this fun way of learning, I actually started with the data analysis in SQL career track, and that's ran for a period of 100 days also. So catch those live streams also on the channel to upskill yourself in SQL, known as SQL. So when we definitely finish this Power BI learning journey, we are moving to the data analysis with Python. If I have to subscribe again to the DataCamp platform, I'll do that because this is a fun way of learning. So also do not forget to subscribe so you won't miss the learning journey of Python data analysis with Python with me over a 100-day period also. So I click on the data analysis in Power BI real quick. So it just takes us to the whole section on this, and it contains 70 courses estimated for 48 hours. And we've covered all the way from introduction to Power BI till where we are today, course number 12 out of 17, exploratory data analysis in Power BI. And we've covered the first 2 chapters, you can see. So we are moving to the EDA category, which is how exploratory data analysis teaches you how continuous variables actually affect categorical variables. So you want to know about categorical variables and their relationship with continuous variables. So let's move on to the course. Let us just continue real quick. And do well to support the channel and share your thoughts with me in the comment section. So welcome back to day 50. Okay, this is day 50.
Hi again. My name is Maarten, and I'll be the second instructor for this course. We went through the first 3 steps of the EDA process and focused primarily on understanding continuous variables. Now we will introduce more categorical variables into the analysis, which will also move us into the 4th step, examining and quantifying relationships between variables. The first place to start is with frequencies, or counts, of observations per value of the categorical variables. If you remember, this is similar to a histogram as described in the previous video about distributions. Here we have a bar chart showing the frequency or number of participants in the study for 3 age groups. Viewing in this way helps us understand the characteristics of the dataset. There are more older participants. Maybe more insightful is the percentage or proportion each value accounts for within the dataset. This can showcase a more relative understanding. 18 to 29-year-old participants sound like a lot unless the total sample size is 10,000. Looking at how proportions vary across another categorical variable can illuminate significant differences within the dataset. Here, you see TikTok is used more by participants ages 18 to 29, while used by few ages 40 to 49. Analyzing in this way can start building insights about the effect of one variable on another. You can also identify trends about a continuous variable by exploring the differences of descriptive statistics across values of the categorical variable. Box plots are a great method for visualizing the distribution of a continuous variable. They are similar to histograms from the previous chapter. The median is the line within the box. Remember, this indicates 50% of values fall below the line and 50% above. The box is the rectangle constructed using the interquartile range. The lines, or whiskers, extend from the edge of the box to 1.5 times the interquartile range. Therefore, outliers, typically visualized as points, extend further than the whiskers. Box plots are fantastic in comparing distributions across a categorical variable. Placing each side by side, you can derive quick conclusions about differences. Typically, you will see the categorical variable on the x-axis and the continuous on the y-axis. Here we see the distribution for heights between males and females. The box plot for males indicates, generally, larger values for heights compared to females. An important part or result of EDA is creating new variables, both continuous and categorical. Doing so can help further refine an analysis or visualization. This process is often referred to as data transformation or mutation. For example, converting the age of a person into 4 age group categories, teen, early adult, adult and middle age, or mining a text string variable to create a new categorical variable, for example, DataCamp course type. Now it's your turn to explore categorical variables and build box plots to compare distributions.
Okay, so we focused on histogram versus box plots on this chapter. So it says histograms and box plots are both great for visualizing distributions of a continuous variable. Each has their strengths. Therefore, which one you choose for your EDA depends on the question being asked. It says, the instruction says, choose the visualization which best fits the item description. It says, box plot, histogram. So it shows intervals of bins of values, intervals of bins of values. Definitely histogram. Better view of distribution statistics. That should be box plots. Outline the first, second, and third quartiles, definitely box plots. Frequency of value. Frequency, that is the occurrence of value. That's frequency. So we are known to have frequencies on Instagram. Better view of underlying distribution. Let's go for box plots. Lines indicating lower and upper bounds for outliers, definitely box plots. Most commonly occurring values. You could see that in histogram real quick. Indicates the median. That's box plot though. Then one of these should be here. I'll go for this beta view. I'm not sure. Oh, great. So look at the beta view of underlying distribution. Definitely the histogram. It shows the overall distribution within your data sets. So well done. Histograms and box plots have their strengths. Now you know when to use which. That's interesting. Let's continue. So exploring variables with Airbnb data.
In this video, we'll be exploring categorical variables using the Airbnb dataset. Specifically, I'm interested in finding the city with the best accommodation and booking rates for a last-minute trip. First, we'll just understand the number of listings per city. I'll create a new table, first add city to values, then the listing ID as a distinct count. This table can be easily visualized as a bar chart to show the frequencies of each city within the dataset. Click on the stacked column chart to create a new instance. Similarly, add city to axis and listing ID as a distinct count to values. Both Sydney and New York have just over 2,000 listings, which is more than Paris and Rome at around 1,500. How many people do these listings typically accommodate? Does this vary by city? We can answer this question by adding the accommodate variable to the table, then modify the summarization to be a median. Rome has a median of 3, while other cities have a median of 2. It can also be visualized using a bar chart, so I'll create a new stacked column chart, adding city to axis and accommodates as a median to values. Now we can visually see the difference between cities. Say my partner and I are looking for an Airbnb for a possible last-minute weekend trip. Which city has the most listings that are instantly bookable? To explore this, I'll add another variable to this chart showing number of listings by city. Specifically, the instant bookable variable to the legend. True, or the instantly bookable listings, are represented by the dark blue. To see the proportion across each group, I'll change the chart to a 100% stacked column chart. Not only do the listings in Rome accommodate more people, but a higher proportion can be booked instantly. Good to know. What if we did need to book instantly? Which cities have better acceptance rates from the hosts? One way we can answer this is through looking at the distribution of acceptance rates by city. Box plots are a great visualization. To create one, I'll first add a new page, then click on Box and Whisker Visualization by Mac Software. Note that this visualization is not by default available in Power BI. It needs to be imported from the Power BI Marketplace, which can be accessed by clicking the 3 dots in the visualization pane, then choosing Get More Visuals. For the exercises, it will be preloaded into the Power BI report. I'll then add host acceptance rate to values, then city to axis category 1. Adding listing ID to axis will help the visualization properly display the information at the individual listing aggregation. The y-axis isn't formatted correctly. We can change that by going into the Format tab, then y-axis, and here we want to change the number of decimal places to 2. Then let's make sure the y-axis starts at 0 and ends at 1, since the host acceptance rate will only take values of 0 to 1, or 0% to 100% acceptance rates. Let's revisit the components of box plots. In this box and whisker visualization, the dark area represents the distribution between the first and second quartiles. The light area represents the distribution between the second and third quartiles. We can see the median, or the second quartile, as the line in between the light and dark shaded areas. Hovering over each box will provide further metrics in the tooltip, including IQR, minimum and maximum. Looks like even though hosts in Rome are more likely to allow instant booking, they do not accept as often as hosts in New York or Sydney. Now it's your turn to analyze categorical variables and build box plots using Glassdoor reviews data.
Wow, interesting. Let's see how we can work with box plots specifically on Instagram. So analyzing a categorical variable. So most data sets are going to include a mixture of both continuous and categorical variables. The latter can add important color to an analysis and be helpful for discovering patterns. Therefore, it is important to be familiar with the basics of how to explore them, especially in relation to continuous variables. Okay, so in this exercise, you do just that, looking at job roles and differences in average or monthly income. Okay, job role and the difference in average monthly income of each job roles. Okay, so open a Power BI report named single categorical. So let me just open my Power BI report real quick. You also have access to all these reports following the link under the YouTube description. So do make sure to download the data sets and practice immediately. Exercises. So single categorical variable. So that is coming up. So I have to load the CSV file class.csv into the reports. Okay. So we've actually loaded that earlier. We just went straight to the get data text CSV. Oh, it's just coming up. So go to get data. It's a CSV. Click on loads and it just loads into your Power BI report right here. So we have our data sets already loaded. And if we just take a quick view of the data sets, we have the review ID, the age, attrition, business, travel, daily rate departments. This is the review ID. Distance from home and the age of the employee, probably, definitely. We have the education and educational level, education field, employment counts, environment satisfaction, gender of the employee, the hourly rate, job involvement, job level, job role, job satisfaction, marital status, and all many information that we could see here, review date key, and so on. So this is quite how many number of rows? Just 500 rows of data right here. So let's move on to the next instruction. So create a table showing the distinct count of reviews per job role. Distinct count of reviews by the job role. Count of reviews. Let's see, probably we have a job role column. This is a review ID. Review ID. We also have review date key here. Okay. I think we only have review, two review. Let me just look for review columns. We have review relationship satisfaction. We have review date key, review ID, and year in current role. But we have a job role there. Okay, we have a job role column here. Okay. So that makes sense. It's probably one of the review. Probably this review should be the distinct count. Let's see. So let's drop a table though. The instruction says drop a table to show distinct count of review per job role. So let's go for job role first. We have the job role here. Why you give me a sum of my job role? Do not summarize. So it's actually summing the job role column. That's quite funny. And the job role column is a, is a text data type. Why is it not summing it? But to get rid of that, we just come here under summarization. I'll tell you to do not summarize. Oh, oh, this is job level. I chose job level rather than job role. Okay, my bad. So you can see my mistake there. I chose job level instead of job role. So of count of reviews per job role. So the review column, we'll have to review date key and review ID. I'll look for review ID. Hopefully that's it. We want a distinct counts of that. And let me just format this real quick and make it visible, more visible. I'll go to the format tab real quick. And let's look at the values. I think it's big enough now. Okay. I think it's more visible now. Better. So since we have a distinct count, So we have the distinct count of I think we have more laboratory or research scientists are more available. We have more job roles, more employees in the research scientists category. Okay, let's move on though. So visualize the counts per job role with a new clustered bar chart. Okay, what I'll just do real quick is to save time. It's to just copy and view. So I have two, and I'll just change my charts here to a clustered bar chart. Easy, easy peasy there. Let's create more space. Mhm. As I said, we have more research scientists, then laboratory technician job roles, and we have sales executive. Okay, so update the table to add monthly income as an average. Sort, sort so the highest average monthly income is in the first row. Let's add monthly income to the table, to this table. Let me just bring this a little bit here, make this wider. So let's add monthly income to that. I have seen that here. Monthly income. We want the average of monthly income, not the sum, the average. Then we have to sort it such that the highest monthly average monthly income is in the first row. Then I could just go to hold up, where's the sort button? Oh, right here, is what I'm looking for. Sort by average monthly income. Then we have to sort descending. Okay, descending. So the manager earns more. So the manager roles, job roles are earning more, and the lowest average monthly income are the sales representative. Okay. Visualize the average monthly income by job role using a clustered bar chart. The highest average monthly income should be on the top. So visualize the average monthly income by job role using a clustered bar chart. So average monthly income by job role using a clustered bar chart. I think we have a clustered bar chart here. Okay, what I'll just do it quick is to copy this. So I'll just remove count of reviews and change instead of job role by count of reviews to job role by monthly income. Then I want the average of the monthly income and the sum. So you see the manager as we saw here, and the manager is the first. Let's make this smaller and make this bigger a little bit. Okay. So you see that the manager is uh, has the highest average monthly income, followed by the research director, followed by healthcare representative, then sales executive. A second there. It says, so we've done that. It says add a constant line for the average monthly income. Make sure to format the label so it is readable. Add a constant line. A minute. Yep, we are back. So we have to add a constant line for the average monthly income. Make sure to format the label so it is readable. Okay. I'm gonna switch off my camera as my power source and my key light is having technical issue. So let's continue to add a constant line for the average monthly income. Make sure to format the label so it is readable. Let's add a constant line to the average monthly income by job, definitely by job role, because that was the last instruction. It said visualize the average monthly income by job role using a clustered bar chart. The highest average monthly income should be at the top. Then the next instruction says add a constant line for the average monthly income. Make sure to format the label so it is readable. Okay, let's move. So if I click on this, then we go to the format tab. The other reference, you could add a constant, add a line. Then the type of line should be a constant line. Okay. On which value do you want to add a constant line? It should be the average monthly income. Monthly income, but the summarization should be average. Okay. Summarization should be average. Let's click on OK. You can see the constant line is visible. Okay. It says make sure to format the label so it is readable. The label should be readable. Okay, I think what does that mean? Transparency. Let's let's change it to red so it is readable. More colors. We want the red constant line. Okay, so it says data label. Okay, the data label is, let me make the data label readable. We make it black. uh, can we make it bold? What the color we could give it that to stand out? Style, data value, position. You can see if it's under or above. You can see the number here. This constant line, this 021.55. Let's click it back to above. Let's leave it on the right. You can't do more than that. I can't make it bold, but it's actually quite visible here. Very tiny. Okay, so that's the constant line. So what value is this constant line giving us? Let's see. It says how many job roles are above the overall average represented by the constant. How many job roles, okay, are above the average? So we have 1, 2, above the average. Oh, cool. 1, 2, 3, 4, 5. We have 5 job roles are above the average monthly income by the constant line. That is 5. That's right. So 5 job roles have a higher average monthly income than the overall average for the example. Managers are making almost 3 times the average job role. That's interesting to see. So that's what this information is giving us there. Just make it a little bit bigger. You can see the managers are making 3 times the average. So I think this is the average monthly income. The average, yeah, definitely the average, because our constant line value is giving us the line, the calculation there. Oh, I've removed the calculation. We can just add it back. The calculation we did was monthly income, what the average of the monthly income. So this is what this constant line is showing us. Interesting. So because the managers are making more money, 3 times the average monthly income, and there are 5 job roles that are way past the line of the average monthly income. Interesting. Let's go to the second challenge. Proportions with categorical variables. So patterns of influence can emerge when analyzing one categorical variable against another. These patterns can then influence the direction of the analysis to understand the why. In this exercise, you will analyze job roles versus marital status to determine if one type is more likely to lead to a single's life. Okay, let's continue. On a new page, name proportions. Okay, let's create a new page. So we have done with this analysis here. Quite interesting. Let's call our new page for proportions. Oh, I didn't spell that correctly. Proportions. So on the new page, name proportions. Create a matrix of job role by marital status, showing the distinct count of reviews. Okay, job role matrix, not a table this time around. We are creating a matrix. It's different from a table. This is a matrix. So to say job role by marital status and showing a distinct count of reviews. The first is the job role. Let's drop in the job role. This is job role right here. That's the job role there. I can just make it a little bit. Let's look for the marital status right here. Marital status, divorce, single. Then the review ID by that. But we want the average distinct count of review ID. Distinct count. I think both the count and the distance are giving us same results. Testing. Yeah, definitely because we've 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 categorized them by two categorical variables. That's why. Okay, showing distinct count of reviews. Or can I just make it a little bit bigger and should be more visible? Let's do that real quick in the format section. Let's go under values and just increase the values a little bit there. This is much more better. So we could see the divorced, married, single. Okay, interesting. So what can we see here? Instead we sort them. Credit sales executive, the laboratory technician have the highest total here. Okay, let's move on though. Let's see. So create a 100% stack column chart of the percentage of reviews by job role and marital status. 100% stacked column chart. Let's see. By the percentage of reviews by job role and marital status. Let me just copy this real quick. Copy view. Since I have double, I can just change this chart to 100% stack column chart real fast. You can see what we have marital status, job role, embedded in marital status. So we could see, so we want to have one of these as a legend. Okay, let's see, create 100% stacked column chart of the percentage of reviews by job role and marital status. One of them has to come to the legends. So that should be the marital status. Let's add the marital status to the legends. Aha, that is now making more sense. Because as those in the human resources, the married, they are more married people. Okay, well after the divorce value, divorce analysis. Well, let's look at this one more time. Okay, interesting. You could see more pattern here. The research scientists are more divorced. They're more single research scientists and less divorced. What do you have more divorced? And we have more divorced job roles there. in the human resource department, but there are more married employees in the human resources than and less single here. Interesting. So add a data labels and round each value to the nearest whole number. Add data labels. Hold up. Create 100% star column chart of the percentage of reviews by job role and marital status. Add a data label and round each value to the nearest one. Oh, okay. So add a data label to the chart. Okay, interesting. Let's format the chart. So add a data label real quick. Data labels on. Okay, and it says I should format the data label to the nearest whole number. Nearest whole number, okay. I could just go to values right here. Hold up, is up. This is the value of my data label. All series. Then the options. Formatting is pretty part of. Okay, let's look at the detail. Um, value in decimal, which says auto. Let's see 1 decimal place, 2. Let's see 0 decimal place. Okay, this is better. So if you could see the detail. This is where we actually need to format that. It will be hard finding, but we found it. Then it says, which job role has the greatest proportion of single individuals? I think I saw that under the sales representative. Because 51% of single individuals, the sales representative, compared to others. That's that should be the sales representative job role. Great, that's right. Perhaps being a sales rep can make it difficult to find a soulmate. That's funny though. Interesting. We'll come up with this chat real quick there. So let's move on to the last challenge. And this is the last challenge in this chapter, which is analyzing multiple categorical variables. Interesting. But we still have one more, the box plus challenge. Interesting. So analyzing single categorical variables is great. Looking at the relationship between multiple is where the story starts to come together. Some basic ideas such as counts, proportions, and average by each combination and averages by each combination can uncover fantastic initial learnings and steer the rest of your EDA process. So in this exercise, you start analyzing multiple categorical variables together, specifically looking at the interaction of gender and education against hourly rates. Let's continue. On a new page, name multiple. Let's create a new page named multiple. Let's create a new page called multiple. Okay. So on a new page named multiple, create a matrix showing the distinct count of reviews by gender and education. So let's create another matrix. Let's go to the charts, the matrix. What I could just do to make it have same format, I could come here, copy this my matrix real quick. Control C and come paste it here. So for this matrix now, just change it to showing distinct count of reviews by gender and education. We have my reviews here. I've just changed it to gender, gender, and this instead of marital status, that should be education, education right here. Okay, interesting. I wanted to maintain same format without having to format all over and over again to save time and efforts. You can see that when you look at the genders by job roles and review, you can see that there are more males compared to females in the job role. Let's move on. So duplicate the matrix and transform to a 100% stacked column chart. Let's duplicate the matrix real fast there. Control view. And let's change this to 100% stacked real quick. Okay. But we still need to now change it. I'll give my education level. Let's move education. And let me, I think I should leave. Um, let me add the education to the legend first. Let's see how it will look like. Not good. Not that bad. But I could just change it the other way around. Let's add education here. Education here. Then the gender as the legend. That should make more sense. Interesting and much more better. Because we have more male in the others category. We have, I think we have more female doctors this time around. But the the bachelor order, master degree order, college orders. So let's move on though. Let's move on. So 100% star column chart. To visualize the counts among these two categories, use gender variable in the legend. I thought as well. So if we use gender variable in the legend, that makes more sense. So create a new matrix showing the average hourly rates by gender and education. Let's create a new matrix, average hourly rates this time around. I'll just copy this matrix, Control C, Control V. I'll change the values in here to hourly rates by gender. So I'll just change the counts to hourly rates. There should be the average hourly rates though. It makes more sense to look at the average rather than the total. Let's change it to average. I'll just change that real quick here to the average. Let's see, average. Okay. Who earn more between the male and the female? The male have a higher average hourly rates than the females in total. When we look at the education level, the highest hourly rates are the college degree holders for the male, while for the females, their highest hourly rate are the others in the others category. Probably they have other degree, probably have skills or certifications more compared to college education. Let's move on. So duplicate the matrix and transform to a clustered column chart. Use gender variable as a legend. If we want to duplicate the matrix also, same thing we did here. Ctrl C, Ctrl V. And let's convert this to a clustered. It didn't say 100% stacked or whatever. Just a clustered column chart. Okay. But this time around also, we are going to be using uh, gender as a legend. Interesting. Since it's not 100% stacked, so you could just compare both male and female side by side. Okay. Okay. So we are looking at um, review, distinct count of reviews by gender and education. Then we have the average hourly rates by education and gender. Same thing. So let's move on. Because see, the college degree holders, the males have the highest average hourly rates compared to others, while the master degree holder, also the males. So in general, the males have a higher average hourly rates than the females. Okay. So which educational level has the highest percentage of females and is the only educational level where females earn a higher average hourly rates than the males? Okay, which educational level has the highest percentage of females? Look at the educational level has the highest percentage of females. Those are the doctors, and it is the only level, where females earn a higher average hourly rates than the males. Okay. Hmm. That should be the master's degree educational level. Okay, nope, nope. I think it's doctor. This is the doctor part because the average hourly rate is 64%. It's on the doctor. Let's log that in. Correct. That's right. So people who hold doctorate degrees tend to be also female. In this sample, this is also the educational level where an hourly rate for the females is greater than the males. Interesting to see. See over 60% average hourly rates compared to the males highest. Fantastic. Let's continue to the last challenge. So creating a box plot. So comparing histograms across each category of a variable is useful, but can be difficult to decipher can be difficult to decipher actual differences with the eyes only and may take up lots of space. An alternative and sometimes more useful approach is a box and whisker plot or simply box plot. In this exercise, you are asked to investigate if the career stage influences an individual's monthly salary. To do so, you create a new variable and use it in a box plot. We're going to create a new variable entirely. That's data mutation. Interesting. Let's move on real fast. Add a new page and call it box plots. Let's add a new page. Let's call the new page box plots. So create a new column called career stage using the switch function. If total working years is less than or equal to 10, set the new variable to early. If less than or equal to 25, set to mouth, and if greater than 25, set to tenure. Otherwise, set the new variable to NA. Let's take a deep breath. Okay, create a new column called career stage using the switch function. Total working years. Let's look at the column called total working years. We have it right here. Oh, hold up. Training, okay, this total working years is here. See? So we have different total working years from 0 total working years to 40. Okay. So let's create a new column using the switch function. So we're going to call this new column career stage, which is going to be equals to using the switch function. I want to switch those values. So when we are switching is total working years, comma. Then the first value is if the total working years. So if total working years is less than or equal to 10, set the new variable to early. If total working years is less than or equal to 10. Okay. Okay, how do we do that? I want to remember how to make use of the switch function. We're just going to point to the first value, the value in the column. We're going to point to the value and change the result one for that value. So value 1 is 10. We want it to be less than. Hold up a minute. I want to switch my keyboard real quick. It says If total working years is less than or equal to 10, set the new variable to early. If less than or equal to 25, set to mouth. And if greater than, we say less than 10, less than or equals to 10. So result for that, if total working years is less than or equal to 10, result for that is early. Let's give it a shot. I can always edit it if I'm wrong. That is the result for 10 value there, comma, value 2. If less than or equal to 25, set to mouth. Okay, less than or equal to 25, comma. So we have another that will be greater than 25, comma. What should we call that? If greater than 25, set to tenured. So that should be called tenured. Lastly, result else. If none of this, that will just give that. Otherwise, set the new variable to NA not available. Just set the new variable to NA, else value there. Let's close that. We're just replacing the numbers there to something else. Let's log that in. Ooh, function suite does not support comparing values of type integer with values text. We're not comparing integer. Okay, see, it is seeing all this my column. Okay, let me remove that real quick. Then I'm going to be getting okay. Who? What is wrong? Let me just take a hint because I'm misplacing my switch function, which is bad. Okay, switch to, oh, I didn't add the true function. Right click on the glass dot dataset and choose new column. The dash function should look like, I didn't add the true part of it. I'm only using switch directly. That's not fair. Less than equal to 10. So I need to add the switch to it. I need to add a true to the function. Then two. Okay, let's see. Let's see. Switch to comma. I need to add my comma real quick there. Okay. What am I missing? I'm missing something. I'm definitely missing my quotes. What am I missing here? What am I missing here? Switch to glass door. Total working years. I'm missing. I think I'm missing this. Total working years less than or equal to 10. I definitely sure I'm missing that. Comma. Total working years. Then finally, total working years. Okay. What am I missing? So that function should look like this. Switch to, let me just look at that. No, 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 not this, not this, not this, not this. I'm looking at my function. Mm, I'm gonna have to complete this off live stream because I have to attend to something really quick now. Switch to Glassdoor, total working years. If total working years, what am I missing here? Okay, I think I'm missing something. I've seen my mistake. So I was adding, so once I use switch to, I'm supposed to be adding the total working years as a variable in the switch again. That was my mistake. So let's look at it real fast. That's interesting. I was able to solve that. So let's look at that at the end here. You can see, so we have our career stages now. We have early. Oh, we have just only early. That means I'm missing my function is not correct. My assumption needs, it says less than. Okay, let's see. Oh, where did I miss that? Switch to less than or equal to less than or equal to 10. Oh, my less than is greater than here. Look at me. I'm using greater than rather than less than. So let's look at it one more time. Okay, now it is now better. Give me correct. You can see early, mild, tenured. Okay, now let's look at the last challenge there. Okay. So you can see you need to know the difference between less than and greater. Now create a new box plot showing the distribution of monthly income by character using the review ID as the aggregation level. Let's create a new box plot real quick. Real quick. We have our box plot here. We have the using monthly income by career stage. Monthly income. Then the career stage. Our new data mutation career stage. And we're going to use the one final level. Then using review as the aggregation level. Aggregation level is the review ID. Okay, let's see. What would that be? Let's look at the review ID. Review ID there. Uh-oh. Where would the review ID be at? Okay. Let's see how the instructor did it the other time. Just curious really fast.
I'll then add host acceptance rate to values, then city
Okay.
to axis category 1. Adding listing ID to axis will help the visualization properly display the information.
You can see is the axis and the axis category, then the value part. Now let's look at this one more time. I think we need to format it. Is the formatting that is the challenge. I think the review ID should be the summarization of the review ID. I guess less summarization. That's interesting. Monthly income should not be sum. Okay, I think that's where the challenge is. So let's look at it says create a box plot as the box and whisker may by making is made available for you. If you want to learn, create a new box plot showing the distribution of monthly income by character using the review ID as the aggregation level. Duplicate the box plot and add gender so that it compares males and female within each state. Okay, I'll definitely be doing this off live stream, but the answer is already, but I'll just come back and complete this as I need to attend to an emergency real quick right now. Okay, so we just complete this and I'll show you what it looks like in the next day live routine. That is day 51. Just to quickly show you what that part looks like. Okay, so I'll definitely be stopping here right now. So I'll definitely be stopping here right now because I need to attend to an emergency real quick. Right, so I'll just complete this last part for this box plus challenge off live stream, I'll probably show you what it looks like on day 51. That will be the first thing I will show before we move on to the new course. Alright, so stay for staying to the end of the live stream. If you found value in this learning journey with me, this Power BI learning journey, do well to support the channel by giving the video a thumbs up, hit that subscribe button. If you're learning something new, if you're learning something and gaining the knowledge while learning Power BI with me, do well to support the channel and share your thoughts with me in the comment section. And I will see you on day 51 live stream where we're going to be starting a new course. I'm going to show you the ending part of this actual Box Plus challenge. Have a wonderful day. Bye. Hit that subscribe button. Go watch the next Power BI lesson on the channel. Peace out.